And we are going to first record the elevator pitch for several minutes and then go to the main part. So let me start the recording and then please start the first part. So let me start the recording. Yes.
Let me start by briefly summarizing my talk in 5 minutes. So in my talk, we will study and we will propose. I will propose and I will study the correspondence between the 3D n equals 4 rank-0 CFT, denoted by T rank-0, to some 3D non-unitary, a pair of a non-unitary TQFT, which is denoted as a TFT plus minus T rank-0. And by rank-0 means that there is no so there is no Coulomb branch or Higgs branches. So the specular moduli space is trivial. There's no Coulomb branch and Higgs branch moduli space. So in a sense, this is the simplest class of 3D n equals 4 CFTs, 3D n equals 4 CFTs. But such a theory has been ignored overlooked in the literature, because some people believe that there is no such a series. This is because that, as we will see in the main talk, so most of these rank-0 CFTs are non-Lagrangian series, which does not have some weakly coupled description with a manifest n equals 4 supersymmetry. So this only allows the UV description, weakly coupled UV description with a less supersymmetry, and it will have a Suji enhancement to reach the n equals 4 supersymmetry. So this is a very interesting class of the 3D n equals 4 CFT, which has been ignored in literatures. So we will study this CFT, and the physical observer of this series as a local CFT as a correlation function of a local operator and loop operators. And in general, it is very difficult to solve because even numerically, solving some component field theory is always difficult. And in this talk, we'll consider some decision limit, which is called the Coulomb or Higgs branch limit. I'll explain in more detail later. Then we claim that this theory will become a more simple theory, which is given by the non-unitary TQFTs. And there in the TQFTs, the physical observers are all the correlation function of loop operators, and it is exactly solvable. And non-unitary TQFTs are mathematically given by so-called non-unitary modular tensor categories, which is given by some symbols with some subjected to some algebraic relations and some gauge equivalence. So this is a very well defined mathematical object. So as a non-trivial dictionary, we will propose that this F is the free energy of 3-sphere free energy of this rank-0 CFT, which is the most basic quantity of 3D CFT. It's simply given by related to this modular atom matrix of topological field theory in this simple way. So using this correspondence and using dictionary, what we will do is that we will derive this lower bound of F, which hold for any rank-0 n equals 4 CFTs, and also it is believed that it is maybe or for any rank-0 CFT. N equals 4 CFT, this is bounded unit saturated. This can be derived from simply using this relation and some basic factor of the unit topological field series, saying that the ground state generality of this genus limit surface can be written as some expression of the S matrix. Then this information and combining this one, then you can derive this lower bound only using the middle school mathematics. And in this correspond, we also give some physical realization of non-unitary, three-dimensional non-unitary topological field theories. So unitary topological field theory cases, it is very well known that this capped plus one-dimensional content system at the IR limit will described by the non-unitary TQFT. But for non-unitary TQFT cases, although we know that there is such some mathematical structure exists, but there is no intuitive physical realization, and this correspondence gives us some concrete physical realization of the non-unitary TQFT. That's the end of my summary. And Let me start my main talk.